Hello everybody and welcome to another mystery box function challenge. In the purple mystery box there is some math and your challenge is to figure out what it is. You can use the link in the description to try this out, and when you think you've got an idea, come on back and see if we get the same thing. All right, let's start with a 0. Okay, 0 gives us 0. How about a 1? Oh, that is weird. Okay, so it looks like 1 point something, but way at the end, it's very tiny to see. It says e to the negative 16. So that is an incredibly small number. There should be, 16 zeros after the decimal point before the 1 even starts. So basically that's 0, I think. What an odd result. It does look like a non-repeating decimal. So whatever function could give us a very, very small, almost 0, but non-repeating decimal. How about a 2? Huh. And that's pretty similar. It's slightly below the line, although you can't tell that by looking at the graphics, but it's got a negative sign in front of it. But again, negative 16 is the exponent. This is very strange. How about a 3? Okay, something similar again. What in the world is going on? How about a negative 1? And that's the same. I guess I'm going to have to look between these points because I seem to be getting basically the same result every time. Although they're alternating positive and negative. So that's maybe trig. Maybe I've got a really, really tiny amplitude trig function here. I don't know. Let's try 1/2. Oh, and now I'm exactly at 1. Huh. Let's try 1.5. Oops, that is not 1.5. That's all right. That's a useful point anyway. Oh, so that is a curve for sure. Now let's actually try 1.5. Now we're down at negative 1. Oh, okay. I think I see what's going on. I'm going to put in a couple more points here. 3/4. Maybe 1.2. And maybe 1.8. I'm going to put in a negative 1/2. Okay. Well, I think I've got this figured out now. It's something I don't think we've actually seen or talked about before. So this is a waveform. So it looks like one of the trig functions, and I think it's the sine. And just as a reminder, our input is an angle, and then where that angle, that line formed by that angle, intercepts the unit circle, we get the coordinates there. So here at 0, for example, it's 0, 1. So the cosine is the x coordinate and the sine is the y coordinate. And at 0, whoops, that's not 0, 1, that's 1, 0. The sine is 0. So that's why I think this is sine. So the thing, though, is that sine would hit its height at pi over 2 and then go back down to 0 at pi. Pi over 2 is about here, and we're way down here. And then, well, we never really put in pi, but let's go ahead and put in pi. So 3.14. And we're moving back down into the next thing already. So the ups and downs are happening faster than they should. So the period of the function is getting kind of compressed. So to do that, you've actually got to multiply something by the x. So let me sketch out a function here. If we had a multiplier on the outside, it would just change the amplitude, how high and low this function goes. But I think we've got a multiplier on the inside, so something times x, and that is going to increase, the frequency of the function, or compress the period into smaller and smaller spaces. So what is going on with this one? What is multiplied? And I think this is kind of a tricky one. Every time I moved 1, I got another 0. And what would do that? I think it has to be pi. Because think of this. This is 0, but it's also 2 pi when you come all the way around the circle. And the two places where the sign is 0 is here and here. So at pi and 2 pi. So if I put a pi in here, every time I put in an odd number, I'm going to get some multiple of pi around the circle. Every time I put in an even number, I'm going to get some multiple of 2 pi around the circle. And it's going to give me 0, 0, 0 every time. Let's think about maybe this point right here where we've got 1/2, because we got exactly 1 there. So let's use that to test this. So the sine of pi times 1/2. Well, that's pi over 2, and that is where the sign is 0. This is the point 0, 1. Sorry, that is where the sign is 1. So that fits, that equals 1 there. Okay, I think we've got this. Let's take a look though. And there it is, the sine of pi times x, and we can graph that as well. So that typical sine function just really squished down. My goodness, I think this was a super tricky one. How did it go for you? Let me know. Thanks, everybody.